Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about two sample...
Hey Jared, dinner's ready.
Mom, I told you not to come in the basement when I'm filming for my class.
Well, I made your favorite. It's spaghetti tonight.
Ooh, spaghetti. Welcome back to Morehouse's Math Menagerie. Today we're going to talk about two sample significance tests with paired data. Let's go to the PowerPoint.
All right, let's go ahead and jump right into the problem. Mr. Morehouse is curious about the number of absences students have in each semester. He is suspicious that students tend to be absent from class more during the second semester than the first. In order to investigate this issue, he took a random sample of students from his AP Statistics courses and recorded the number of absences they had in each semester. He was to conduct a significance test at the alpha equals 0.10 level to determine if his suspicion is correct. Here is the random sample of students that he got. Semester 1 is listed in this first column, and semester 2 is listed in the second column. Now, since this data is not independent, semester 1 and semester 2's data both came from the same students, this is going to be paired data. And we're going to want to take and subtract and find the difference between semester 1 and semester 2. Here, I chose to do semester 2 minus semester 1 because Mr. Morehouse is suspicious that semester 2 was higher. Let's jump into the test. We're first going to define our parameter as mu sub d equals the mean difference between students' absences in semester 2 minus semester 1. The null hypothesis is going to be that mu sub d equals 0, and the alternative is that mu sub d is greater than 0. Note this is a one-tailed test, a right-tailed test, because Mr. Morehouse was suspicious that semester 2 had more absences than semester 1, which would make the difference positive. Our procedure is a two-sample t-test for mu sub d. The random selection of students was met. The 10% condition is met. For the normality condition, we're going to have to look at the box plot of the sample differences to see if there's any strong skewness or outliers. Let's go ahead and do that now. In Desmos, I have the absences in X1 for first semester and Y1 for second semester. To get a list of our differences, I'm going to do y1 minus x1 in order to have our semester 2 minus semester 1 differences. This is the same data that was shown in the previous table. To check our box plot for our normality condition, I'm going to type in box plot y1 minus x1 in parentheses, and you can see here we have a pretty nice box plot. The whisker to the left is pretty long, but the box to the right in this third quartile is pretty long, so it kind of balances out. So definitely not symmetric, but not any major skewness or any outliers. So a T procedure is appropriate. Please remember when we check conditions in this way, for normality, we need to draw this box plot with an axis underneath it with labeled values to show that we checked it. Since we're here in Desmos, let's go ahead and run the actual calculations for the test. So I'm going to hit plus, I'm going to hit inference, and I'm going to go to t-test here. For my data, I'm going to type in y1 minus x1 and create the test. When I drop down my significance test menu, now remember the null was 0, but we want a right-tailed test, and so I'm going to change the tail to right. And you can see that we had a test statistic of 2.818 and a p-value of 0.006. Before we wrap up our problem with our conclusion, here's a lovely pie chart. The p-value of 0.0065 is less than alpha of 0.10. Thus, we reject the null hypothesis in favor of the alternative hypothesis. There is sufficient evidence to suggest that the true mean difference between students' absences in semester 2 and semester 1 is greater than 0. Thank you for watching this video. I'll leave you with this comic strip. Have a great day.